Hello everyone, thank you for joining. My name is Brittany and I want to welcome you all to our webinar today. The topic is a Microsoft Azure overview, the developer perspective. First, we'll talk about a couple optimization tools, then I will introduce our speaker, Peter Thorstensen, and he will take over and give his presentation. Then we will have Q&A for any questions you might have for Peter. And this webinar is being recorded and will be available to you by Thursday of next week. My email address is brittany.morin@360training.com, so feel free to email me if you have not received that email. To optimize your experience during this webinar, feel free to ask questions by clicking on the message icon and typing in the box at the bottom left. And if Peter sees that he can answer your question without going too off topic, he'll answer it then. Otherwise, we'll wait until the end during Q&A. And if you don't want to see the chat section, go ahead and click the X at the top of the message box. And now I'm going to hand it over to Peter, who will give his presentation.
Hello, thank you for that introduction. Can you hear me okay?
We can hear you.
Very good. Well, my name is Peter Thor. And let's see, I want to share my screen. So I click on Present Now, I guess, do I?
Yeah, go ahead and present now.
Yes, okay. So that's not my screen. Hold on.
Oh, no, yeah.
I have to go here. Now it should be presenting my screen. Okay, so you can see my screen share, correct?
It's loading, so let's see. Yep, we can see your screen.
Very good. Okay, so I'm going to put that off to the side, and I'm just going to show a couple of slides, and then I'm going to go into the actual slide deck where we have quite a bit of things to talk about. But so, as I said, my name is Peter Thor, and I've been programming for many years, and I have to say that with the recent advent of cloud computing, programming has gotten really interesting. It's always been a lot of fun, but now it's just incredible the things that you can do, things that were never imagined in the past. In any case, this is a talk. It's titled Microsoft Azure Overview, the Developer Perspective. So a lot of people are interested in Azure from different perspectives. We're not going to be looking at it as an administrator or an end user or a software as a service user or anything like that. We're going to take a look at it from a programmer's perspective. And of course, a programmer is somebody who develops software, and they write code in a programming language. Now, .NET has been around for 15 or 16 years now. I actually was involved in .NET when it first came out. As I said earlier, I've been programming for many years. And so initially, the main programming language that we used in the .NET world was C#. Of course, Microsoft recently has really opened things up. So, for example, Visual Studio now is a development tool for developing applications in pretty much any language you can imagine. A lot of programmers are using Visual Studio for writing Java programs, Python programs, C# programs, C++ programs, and not just different programming languages, but also targeting different operating systems and frameworks and APIs, including Azure. And so Visual Studio does have the capability of installing the Azure SDK, and I'll open up Visual Studio and I'll show you the kinds of things you can do with that. We're also going to talk a little bit about the portal. That's a website that's used to manage your Azure account. That's a very rich environment. We won't get into PowerShell commandlets much. I'll mention that anything that you can do in C# programmatically, you can do in PowerShell commandlets as well. And in fact, PowerShell commandlets, PowerShell itself actually is a full-blown programming language. It's actually an object-oriented language, which is just as capable as C# is, for example. Of course, I'm an old-time programmer, so I'm not that keen on PowerShell, but of course, administrators love it because they can do repeatable and reliable scripts that can be performed over and over again in a way that's very easy to manage. So you can use the portal to interact with it graphically in a web page, and you can also use commandlets to do it as an administrator would typically prefer to do it. And then there's, from the programmer's perspective, all of those management APIs that are available to PowerShell and within the user interface of the Azure portal, all of that is actually accessible to us in C# code as well. So we can actually write C# programs not just to create applications that run in Azure, but also applications that interact and manage it. So as we see here, we're going to talk about Azure. It supports a broad selection of operating systems, programming languages, frameworks, tools, and databases. And so in this webcast, we're going to take a survey of the relevant development tools, including the Azure portal and Visual Studio. Now, I did mention a lot of programming languages are supported. It turns out that Azure also supports other operating systems. So you can actually spin up virtual machines that run Windows, but also Linux. Many different flavors of Linux, in fact. And it's not just SQL Server. You can run Oracle or pretty much any other relational database in the cloud as well. And not just relational databases, but also NoSQL databases, which are very important these days. So DocumentDB, Redis Cache, CouchDB, MongoDB, and so on. And big data, HDInsight, and Hadoop, and artificial intelligence, neural networks, machine learning, all of these things are possible. Of course, we only have an hour, so we're not going to be able to talk about everything. What I am going to try to do, though, is I'm going to try to mention as many things as possible without going into too much depth. From a programmer's perspective, you're probably going to want to see some code. Of course, the problem with that is that there's a whole bunch of different languages, and you can do the same thing in multiple different languages. There won't be enough time really to do that, but I will point out a whole bunch of URLs that you can go to in MSDN and on other websites where you can find code examples that you can download and open up in Visual Studio and pretty much just deploy right to Azure, and within a few minutes you can see fairly complicated and interesting examples up and running within your Azure account in virtually no time. So anyways, we're going to take a look at my slide deck here. So I'm going to switch over to this slide deck, which is a little bit plain vanilla. So the main thing about Azure, and you probably know this, is that, and this is true for not only Azure, but also Amazon Elastic Cloud, as well as Google App Engine and other related cloud hosting services. Those are the three main ones, though. So Google and Amazon and Microsoft are the three main providers. There are others that are in kind of specialized areas like Rackspace and so on. But in all cases, basically what we're interested in doing is converting capital expense for hardware purchases into operational expense. And that means that you only have to pay for what you need and when you need it. So you can spin instances up and down, you can scale out, you can scale up, you can scale down. You can auto-scale based on metrics that trigger changes in scaling out, for example. And so the idea here is fixed costs as opposed to variable costs, which is very good if you're creating let's say a new website and you don't know how successful it's going to be. It could be a huge success or it could be a failure. You're hoping that it's successful, but you don't want to outlay a lot of money for setup to create your own data center only to find out that unfortunately it just didn't work out, and all that investment is down the tube. Do you remember the .NET, I should say the .com bust? It was a boom and a bust. In the 1990s it was booming, and then around 2000, 2001 it just, the bubble burst, right? Part of the problem was the huge investments and the huge risks that were involved. And of course, not all of those ideas on the web could work. Only some of them ultimately would. But anyone who wanted to play the game had to pay that huge investment in setting up their own data center. This whole idea of cloud has actually been around for many years. It goes right back to the 1960s with IBM's OS 360, which is in 1964 came out with time sharing on a mainframe. Now, of course, it's evolved a lot. It's become a lot more complicated and interesting and flexible and powerful, but that same idea has been around for that long. And I remember back in the 1980s, Oracle and Sun Microsystems and various companies from time to time would promote this idea, but it never quite caught on. This whole idea of client-server, at the thin client, and all of these ideas were in development, but it took a very long time for it actually to mature to the point where it actually caught on. And now it's caught on in a huge way. And I would say that pretty much all computing in the future is going to be cloud-based. The operating system that we had on a PC, Windows, and even the Mac for that matter, I do predict eventually those will gradually disappear or become insignificant, and it's all going to be mobile devices accessing cloud-based services. It's not going to be 100% eliminated, but there already is a massive shift. If you just take a look at statistics that you can find easily on the internet that shows the amount of HTTP traffic on the World Wide Web and how much of it is coming from client-side applications and browsers that are running on a desktop operating system like Linux or Windows as opposed to from Android or iPhone. Anyways, let's take a look at what we have here. This is a picture that I found. It's a promotional picture that Microsoft provides, and they allow usage in PowerPoint slides like this. But this is just one of many locations around the world where they're building these massive data centers. And they're actually quite interesting. This link here, I forget what's actually in that link. It probably takes you to a tour. Let's see. Actually, I have a whole bunch of links here. So, for example, this is the regions around the world where Azure has their data centers. There's quite a few of them. And this is a web page on MSDN that talks about the vocabulary. So this is a glossary. I'm not going to go through it all right now, but I should probably make available all of these links that I'm talking about. I'm not sure how we should do that, but sometime near I guess during the question and answer period, maybe we'll figure that out. I can put this on a file on a Dropbox folder and provide that link to you. But basically, we don't really have time to go through this, but all of the terminology here is useful to become familiar with. So, for example, this Azure Command Line Interface, that CLI, that's called a cross-plat or an X-plat CLI, which allows you to interact with, it's not actually PowerShell, but it's similar to PowerShell, and you can use it on Windows or on Mac OS X or on a Linux-based PC. And georeplication and load balancing and portal and regions and resources, we'll talk about some of these things, but there's a lot of terminology that you have to become familiar with in order to be able to talk about Azure. Now this, for some reason this browser is hung up. I don't know why that is. I'm actually going to have to probably bring up my task list and shut down Edge. You know, I've noticed that Edge is sometimes a little bit misbehaving these days. Okay, so I haven't lost you, I hope. Maybe what I should do is just go back to Internet Explorer.
Yeah, Peter, all we see right now is, I mean, for me, a black screen.
Oh, really?
Yeah.
So I'm gonna, okay, that's Microsoft's Edge browser that's been acting up, and
Okay.
So let me pop out and back in again.
Sure.
I'll be really quick, okay?
Okay. Sorry, everyone, for this small technical difficulty that we're having. If you guys do have any questions, though, please make sure you answer or ask them in the message box, and Peter will get to them.
Okay, I'm back. Can you hear me?
I can hear you.
And okay, I'll show my screen now.
Okay.
Sorry about that, folks. Okay. So are we back to normal now?
It is loading. Yep, I can see your screen.
Okay. So let me bring back the PowerPoint slides. Now, I'm not actually monitoring the questions here, but
There haven't been any so far.
Okay,
But I
and
did
you'll...
remind people to ask them in the message box.
Okay, very good. So the next link that I want to quickly go to, let's see, did we see this one? Yeah, so those are the regions around the world. Yeah, okay, sorry, so we got that. Okay, so this is a nice little picture that shows you the difference between the choices that we have. So the traditional approach is on-premises, and I'm going to bring up a little tool called Zoom It so that I can sketch on the screen. And so as we see here on-premises, so everything in blue is for you to manage, right from the top level application all the way through down the stack, down to the networking, right down to the hardware, basically. Now, Azure supports infrastructure as a service, platform as a service, and software as a service. So software as a service would be like Office 365 or Visual Studio Online. And so other examples of other companies that create software as a service would be things like Salesforce. So that you're probably all familiar with those kinds of things. And in that case, the end user sits on top of this big stack of green stuff. And green means that you do not have to manage it for your users. It's managed by Microsoft. It's managed automatically as part of that service. Platform as a service, you have a little bit of blue and a fair amount of green. So the green is the stuff that, again, you have to manage. You're responsible for managing that. The blue is what you are responsible for, and the green is what Azure is responsible for. So platform as a service, you're responsible for writing the code for your applications and implementing the data storage, whether it be SQL Server or Oracle or whatever. And so an example of a platform as a service would be websites and worker roles and web roles. And we'll talk about the various kinds of things that you can do in platform as a service. And then infrastructure as a service, you've got more blue and less green. And that means that you're responsible for more things here. So you're responsible for creating your applications, designing your data. You provide the runtime environment, the middleware, and the operating system. So it's at this level that you can basically lift and shift an existing operating system that you set up, whether it be Linux or Windows or whatever. You can just deploy that onto your Azure account and make it accessible so that people can remote into it. So if it's a Windows server that you've created with maybe SharePoint on it and maybe a few custom applications and some custom configurations in there, you can do that, and then people will just remote into it. So you can use RDP, that's Remote Desktop Protocol, to remote into a Windows box, or you can use SSH, which is a command shell for the Linux end users. But so that's infrastructure as a service, and those are referred to as VMs, whereas these are roles. I'm drawing with a mouse. It's not that easy to draw with a mouse. I don't have a touch screen with me right now. So VMs and roles, and these are apps. They're all apps, but really all the user sees from this perspective is just apps. They don't really know of anything below that. And on premises, you are responsible for everything, and you have to micromanage it right down to the hardware. Okay, so that is the breakdown of IaaS, PaaS, and SaaS. Next link that I wanted to talk a bit about was this one. and that's spinning its wheel. I'm not sure why it's so slow. That one doesn't seem to be wanting to go anywhere. Okay, let's skip that one. Okay, so this is an MSDN article talking about sizes for virtual machines. So you can scale up or scale out. Scale up means you're going to faster clock speeds, larger amounts of random access memory, faster and bigger disks. Basically, you're going to a larger computer. And then scaling out is in the other direction. So scaling out means that you're staying with the same size of computer, but you are running a greater number of instances of it behind a load balancer. So that's the difference between scale up and scale out. Generally, scale out is more manageable, more configurable, and kind of more continuity in terms of managing the throughput that you can handle. But if you're interested in knowing what the sizes are, this is scaling up that we're talking about here. Standard sizes are falling into these categories, which are mostly represented by letters. So A, D, D, S, F, and through to GS. And we don't want to delve into the numbers and the details here, but just be aware of the fact that they do document all the specifics of these different choices that you have. And there's also different family names for each one of these as well. And so lots of numbers to look at. Excuse me. The next thing that we're going to take a look at here is a web page that Microsoft introduces Azure. I'm not going to read this, but this is something that you might want to take a look at. This is an overview, and it talks about the different components of Azure. So we will talk about all of these things, and I better hurry up so that we can get through all of this. But the different services that are provided fall into different areas or different categories. So there's a compute category. So virtual machines. That is that infrastructure as a service that I was talking about. And then websites and web and cloud services. Those are related to platforms as a service. And we don't see infrastructure, we don't see software as a service in here at all. That's another category altogether. But so you can tell that compute is all about providing an execution environment, the hardware and the operating system necessary to run your application. Your software has to access data, and so there is SQL database, and that's different from SQL Server. It's actually very similar, but SQL Server is intended for your own on-premises type of scenario. SQL database is the same thing from the programmer's perspective, but it's less overhead and less management, easier to configure and easier to automate than SQL Server. So you can think of SQL database as basically SQL Server specially redesigned somewhat to be easier to work with in a cloud environment. But from a programmer's perspective, there's no difference whatsoever. You're still going to use SQL. You're still going to use the entity framework possibly. You're still going to use link query syntax and so on to access that data. The only thing that would change from the programmer's perspective would really be, and you can probably guess this, right? Just the connection string would be different, nothing else really. There's also non-relational database storage in the form of blobs and tables, and they don't mention it here. There's also something called queues. Actually, I think that they put queues in a different category down below. Quite often, people will combine blobs and tables and queues basically along with the files system. Those four services are basically part of data management. So blobs are binary large objects, and it's very good for streaming video or very large files. And you can check the MSDN documentation for all the specs on this. There's actually two forms of blobs. There's something called block-based blobs, and there's another called page-based blobs. And block blobs are better for streaming access to data. such as like a YouTube video that streams data. So if you want to do something similar to YouTube, you could do it with that. But it's basically just a streaming kind of a progression through the data. The other alternative is page-based blobs, which is more for random access and jumping around and doing more complicated operations on data. So those are the two kinds of blobs that we can work with, and all of these things are accessible. Blobs and tables and queues, they're all accessible through an API. We'll take a look at those APIs a little bit later, but the interesting thing about this is that these APIs that access storage, they come in several flavors. There's a client API version, which is basically a managed interface. It's a client-side proxy object that implements an interface that allows you to write code that can call into that functionality using a proxy object on the client, and it does the work of communicating those method calls into the actual functionalities that exist within the API on the Azure service. So this is not an API in your application. This is an API that the storage service in Azure exposes, so that you can programmatically access it and interact with it. So there's a client API, which is a managed type of API. There's also a RESTful API. And many of you have probably heard of REST. REST stands for Representational State Transfer. It's a very popular way of creating distributed applications. REST is basically the modern way of creating service-oriented architecture type applications or distributed applications where a client can call into a method on a server remotely, but it does so in a RESTful manner, which is in contrast to the older style of SOAP, which stands for Simple Object Access Protocol. So SOAP is a little bit older, actually not a lot older, just a little bit older, but REST has very much kind of replaced SOAP. So I'm going to put an X through SOAP. I hate to do that because actually SOAP still does have some use. It's actually in many ways more powerful and more flexible and more extensible than REST, but it's also more expensive and more overhead and greater latency and lower, more bandwidth consumption, but it supports all of the web service protocols that some people rely on. So it still does have that usage. But you can think of the SOAP as basically like the big Cadillac, whereas the REST is the little sports car or maybe motorcycle type of approach. It's just lighter, leaner, faster, and more efficient and simpler. But REST is based on HTTP protocol, whereas SOAP can be based on any protocol. It could be HTTP, it could be TCP/IP, it could even be something stranger like FTP or SMTP or something like that, or maybe even a custom protocol. That's how flexible it is. But REST is very firmly attached to the HTTP protocol, which is the protocol of the World Wide Web, and it's also associated with URLs. So we actually structure the contents of URL so that it represents the call to a method, and it represents the parameters that are passed into the call to that method. So examples of REST that you may have heard of are things like OData, right? Check out the OData article on Wikipedia. It's a nice, simple, short read. It's a good sort of starting point, at least, to learn about OData if you're not familiar with it. And OAuth would be another one. So OAuth. Those are both examples of RESTful APIs. And you can also create your own RESTful APIs, and all of the APIs that Azure exposes for interacting with storage and basically everything is done through a RESTful API. So the client API and the RESTful API, those are two main alternatives. There are actually other alternatives, for example, using PowerShell and so on, but let's not worry about that. Let's move on. In addition to storage blobs, there's also storage tables, and there's also the file service. So I talked a little bit about blobs. They're just basically binary large objects. Now tables are quite interesting too. When you think about what a table is, a lot of people will jump to the conclusion, incorrectly, that this might somehow relate to tables within a relational database. Everyone knows that relational database contains tables, and quite often tables have primary keys and foreign keys, and columns and rows, and relationships that represent joins between tables, and all that kind of stuff, along with stored procedures and triggers, and all kinds of things that we expect from a full-blown relational database like SQL database. But these tables are nothing like that. These are really simplified. This is more of a NoSQL kind of a storage. Now there are a whole bunch of other NoSQL storage facilities that are available, like for example DocumentDB and Redis Cache and so on. But the tables are the ones that are built into the storage service. And I'll tell you what NoSQL really means. To me, NoSQL just means that it's not a relational database, it's just key values, right? It's keys and values combined. And so it typically is indexed to increase the performance for searchability, but really it is just a set of key values. So tuples, basically. Objects that have properties, some of which are keys and some of which are values, and we can have an enormous number of them. You can have much more data in one of these tables than you could ever expect to have within a relational database, which gets us into big data, which is a very important concept in modern computing. We'll probably talk a bit more about big data eventually. Okay, so I'm not really monitoring questions, so if there are any questions, somebody will have to pick up and let me know, but otherwise I'll just keep pushing on. We do have a lot to cover. So file service, I think that's pretty self-evident. Everyone knows what a file system is, everyone knows what I/O is and what an API is for doing file I/O. Turns out that Azure supports a file system that is based on blob storage. So you can use a blob to represent a file, and then use the file I/O API to access data within the blob. There's also virtual machines, and guess what? The virtual machine is a VHD file. What is that? That's just a big blob. That's a file that represents the image of an operating system that is stored in a blob. So these blobs are used internally within Azure for all kinds of things that you might not expect. Another thing that happens is logging of information at runtime, event logs and so on. Azure stores all that diagnostic information in blobs, right? And there are APIs to access that data in those blobs as well. Okay, what else do we have here? We've got virtual networks. So Azure allows you to create virtual private networks. There's something called the service bus, which we will talk about. The service bus is interesting because you can have, down here you can have on-premises. That's your on-prem. And some other collaborating company or organization might have their own on-premises. And you might want to create a distributed application that involves both of these organizations. And either one or both of them might have Azure accounts, and they can set up a service bus in the cloud that basically connects these guys up. And so they don't have to do that. I mean, you could do it in a lot of different ways, but the beauty of doing it with this virtual network is it basically drops down to a point-to-point type of connection. And so you can go from HTTP, which is relatively inefficient, one-way simplex type of pattern, and you can drop it down in using a relay protocol, or a relay binding will allow you to have a direct point-to-point, two-way, full duplex, high bandwidth connection. So there's a lot of interesting things you can do with that. There's also Traffic Manager, and I better not go into too much detail because many of the slides that come later actually talk about this and other things. So there's Traffic Manager, there's Express Route, there's Visual Studio Online, which is software as a service. There's the Azure SDK that you can use within Visual Studio, and so on. There's also Active Directory for authentication, and that gets into SAML tokens and single sign-on and certificate authorities and X509 certificates and digital signatures and all kinds of interesting things like that, security token service and so on. Then there's mobile services, which is basically, it's a little bit of a misleading name. It's not really specifically just for mobile devices. That's, I guess, what the majority of usage ends up being mobile devices, I suppose, but really it's, and I'll talk a bit more about this in a little more detail later, but it provides a lot of services on the back end that makes it very easy and very efficient and quick to implement applications that can be used on mobile devices. There's a notification hub which can be used to broadcast messages to mobile devices. There's also backup and recovery, and there's also, okay, this is interesting too here, storage queues, service bus queues, service bus relays, service bus topics. I hope that we have time to get into all of these things, but these are all really important for enterprise level distributed applications. You notice the use of the word queue here. That's not quite the same as the queue that we saw up here. We did see a queue, did we? Maybe, no, I guess they didn't mention it at that point. I'll talk a little more about this later. There are actually two very different kinds of queues. There are queues that are part of Azure Storage, and then there's queues that are part of the service bus. I don't know if you're familiar with BizTalk, but that's used for creating applications that need to communicate and transform data from one XML schema into another automatically and that kind of thing. So that's a very useful tool as well. There's a job scheduler. There's cache, distributed cache for performance. Content delivery network, which basically provides access points geographically distributed around the world so that people, when they access a video that you're hosting, they're going to get it from a local server rather than one halfway around the world to reduce latency. And there's also HDInsight, which is just an amazing technology. That was originally developed, well, I'm not sure exactly, I used to remember the name of the person that first created it, but he was either working at Google or he was hired or his idea was purchased by Google. But basically, this is a HDInsight is based on Google's Hadoop. So at that point, it wasn't actually called HDInsight. I should correct myself. That's actually the Microsoft brand, or the term that Microsoft uses for their implementation of Hadoop. Hadoop is the more kind of generic term for this, which is related to big data and for doing amazing statistical analysis on truly massive amounts of data. We're talking about more than terabytes. We're actually talking about the possibility of even petabytes of data. And in the future, it'll probably even go beyond that. But the whole idea of Hadoop is something called MapReduce. And I wish we had more time to talk about this, but let me give you a very simple example, the kind of textbook toy example that typically you'll see in a first chapter on in a book on this. If you have a classroom of elementary school kids in your class and you take a magazine article and you tear out each page of the magazine article and you hand them out to all the students and you ask that each one of them to count the number of words that are on that page. Each one of them comes up with a number and they give that back to you, and then you add the resulting numbers. So that was a map, and then it was a reduce. There's two stages. The map is distributing the work out to multiple CPUs, and the results are then fed back and accumulated back together in what they call a reduce. So it's map and reduce. So that's a toy example. Not all that interesting or impressive, but it gets the message across. You can visualize that very easily as to what's going on with map and reduce. The beauty of it is that it can take an algorithm and split it up and run it in parallel across a lot of hardware. And it's basically a distributed algorithm for producing results much more quickly than you could on a single processor. Of course, you have to pay for the number of CPUs that you spin up to do this, but remember, you're only paying for it during the brief period of time that you're actually using them. The kinds of things that you can use MapReduce on are truly amazing. In fact, Google uses it heavily internally for scanning every Gmail message that is transmitted through their system, and they can really gather amazing amounts of information and do all kinds of very powerful statistical analysis. And the common theme today is that it's not that they're looking for information. They've set it up so that it actually produces, by way of something called cluster analysis, it actually produces interesting information and patterns and statistics that you never even dreamed existed, that you never even thought to look for. And that's the truly amazing thing about this. The future of medicine, for example, pharmacology, many things that relate to sociology and political science. There's a massive amount of data out there. I'll give you an example. This is hypothetical, but recently they discovered that gum disease is related to cardiovascular disease. Who would have guessed that? Well, if you actually looked at all of the Gmail in the world that you accumulate day after day after day, all you have to do is statistically detect a small bump in a statistic that shows a correlation between email messages that just mention those two things. The email might say, my gums are sore, and then later in the email it might say, my doctor told me that I have hardening of the arteries, and there's no biological reason, no scientific reason, no clinical research evidence beforehand that would have ever led you to believe that, but just by having that data there, and not even looking for it, but having it automatically surface to the top of a cluster analysis algorithm, it can spit this out and just give you this result. So a lot of people are starting to think that data is truly amazing. In fact, there's a phrase for it. I forget who coined the term. You can Google it and look it up yourself. But basically the phrase is, it's referred to as the unreasonable effectiveness of data. Basically, data is much richer than we realize, and it's just a matter of being able to capitalize on it. And Hadoop and MapReduce and Microsoft's implementation, which is HDInsight, extremely powerful. And that's related to many other things, artificial intelligence, neural network theory, self-driving cars, face recognition, voice recognition, automatic spoken language translation from German to French or whatever. All of these things are going to be completely automated because of this kind of development. Amazing stuff. There's also media services, and you can also create applications and put them in the marketplace for other people to purchase. And so, like I said, we could just use this one article here and go through the whole session and just use this for all the discussion that we have to do here. But let me just, I am getting a little behind, so I better go back to my slide decks here. So very quickly now, I'm going to try to rattle this off. Platforms that are supported, Windows and Linux, not Mac, okay, but all kinds of different versions of Windows and versions of Linux. All kinds of languages, C#, Python, Java, C++, Ruby, frameworks, Node.js, ASP.NET, Rails, Django, tools including at the Azure portal itself, Visual Studio APIs, PowerShell, compute services, websites, web services, web roles, web workers, web jobs, virtual machines, storage services, tables, blobs, queues, and files. I've talked about some of these things already. RESTful APIs and managed APIs, I mentioned that. SQL database, DocumentDB, Redis cache, Store Simple. So some of those are relational, some of those are non-relational databases. Big data processing, HDInsight, machine learning, etc. And Azure Service Bus and distributed applications, queues, topics, relays, and event hubs. So this diagram here shows one way of looking at this. So there's a client layer where you've got devices on the client, browsers, smartphones, and so on. The next layer down is the integration layer, content delivery network, traffic manager, virtual networks, service bus, data synchronization. Next layer down, application layer. So compute, websites, platform as a service, infrastructure as a service. So there's your virtual hard drive, there's your virtual machine, Hadoop, right, big data analysis. And then on the back end where we have our data, there's file system, there's blobs and tables and queues, as well as a distributed cache, as well as, well, that's about it. Let's skip that slide. Now, this is a good little place to take a look at getting started here. Actually, I'm going to just do it this way so I can copy and paste, because I don't want to bring up Edge. It blew up last time. So I wish we had time, because I would love to go in here. You should try this if since we don't have time to actually do it ourselves, but right now. But you can click on any of these links and learn more about all of these things. So for example, I've talked a little bit about storage, right? So you can go to code examples, and you can take a look at what platforms you're interested in. So .NET maybe. So pick that one, and it shows you the various code examples that you can actually go through. These are tutorials and sample projects that you can download and so on. So getting started with Azure Table Storage, Azure Blob Storage samples. Take a look at any one of these, and then you can just download the zip file and save that. I'll put that onto my desktop here, and it's just that easy. You can then unzip that and then open that up, and there is the is there a solution file here? Yeah, right there. So I would recommend, quite often it's necessary to uncheck the read-only there, and then you can open that up and you can build it and run it locally within Visual Studio. So Visual Studio has everything you need to do local development and testing on the development machine, but you can also very easily publish it to your Azure account. So unfortunately, this would take quite a bit of time to go through, but I just want you to be aware that you can go and read about what the project does, go through it, review the code, and you can learn a lot about doing that. I should probably not spend any more time on that though, but what I could do is I could show you the Azure, Microsoft.Azure, the portal.azure. So I'm going to log into, whoops, that's not going to work. Change this to, so I have some resources in here that relate to just one virtual machine, which is a Visual Studio 25 machine that I can remote into. So if I go to Remote Desktop and connect in, so this is my remote desktop. It comes up that quickly, and I've got Visual Studio on here, so it's just an RDP kind of a session. That's very easy to create. I'll show you in a moment how to create that kind of a thing. But I'm going to click on New here, and I'm going to just create a web application. And there's a lot of different ways of doing this. So I'm going to give this a name. I'm going to call this My Cool Junk App, just to give it a goofy name. I always put junk in there so I'll know later that I can safely remove it, because it's just a demo. And I'm going to create a new resource, and I'm going to call this My Cool Resource Group. And you can have insights on or off. I'm going to do off. Insights give you statistical analysis of the usage patterns of your website. And you can pin that to the dashboard if you want. I'm going to go ahead and create that. And within just 5 minutes or so, it'll be up and running. So I'm going to put that off to the side and go back to the next item that we wanted to talk about. So getting started with Azure Queue Services, that is another interesting topic. So you can download another zip file there, and there's a nice little project that you can try opening up and running. Try running it locally, try deploying it to your Azure account. There's another, I told you about the word count. Remember I told you about splitting up the pages in a magazine and handing them up to your elementary school children and asking them to count the number of words and then give the numbers back, and then you add them up as a way of parallelizing that work. Well, what do you know? Here's an example right there. It's a textbook example. And so this is a word count algorithm based on exactly how I've described that. That's using HDInsight exactly to do that with a large document. So it could be a document that has a couple of terabytes of data in it, and you can run it on maybe 1,024 CPUs in parallel and get back the results in a reasonable amount of time. There's a lot of free books. Fundamentals on Azure, HDInsight, machine learning, web apps for developers, building cloud apps. These are all free, and these links are available for downloading those ebooks. A lot of free learning material. If you don't have an account, you can go to this link and create an account. You can create a free trial. It does require you to provide a credit card, but it won't charge you anything for it. But if you have an MSDN subscription, you can use that to get a free account. And there's also, you can purchase or various offers that apply in some cases if you're, for example, an MSDN member and so on. So these are the different compute services that are available. Virtual machines, that's IaaS, and then there's websites and cloud services and mobile services. Those are PaaS, right? So infrastructure as a service as opposed to platform as a service. Networking services, virtual network services for virtual private networks, and there's also traffic manager service which can optimize the topology of your virtual private network to ensure that you have the most efficient, low latency, highest bandwidth scenario possible. There's also data services management, business analytics, HDInsight for big data, distributed data caching, backup, replication, and recovery, various app services, media services, messaging services, like queues, for example, service bus queues, notification hubs for sending notifications out to devices in parallel, BizTalk, Active Directory, and multi-factor authentication with Azure Active Directory. And so this is a diagram that shows virtual machines, websites, cloud services, and mobile services. And down this column here, we see data management, networking, business analytics, messaging, caching, identity, media, etc. So you can see the names of these different services in this diagram and how they fall into place. By the way, this HPC scheduler, that's for big compute. So HPC, if I remember correctly, stands for high performance cluster, or high performance computing, actually, I think. And then various SDKs for different programming languages, Ruby, Python, etc. Now there's the old portal, and I showed you the new portal already. The reason I'm mentioning both of them is that quite a lot of code examples and tutorials that you will find when you want to learn about this will be talking about the old portal. You might want to know about both of these so that you use the correct one according to what tutorial you're covering. But pretty much everyone now is moved on to the new portal, which reminds me, we did have this baking in the background. So we have just created this application here, this web app. And so there's the link to it. If I click on that link, it's just going to show me a splash screen. This is just a placeholder. It's there. It actually exists. It's been created. It's up and running, but I haven't deployed anything to it. So why don't I deploy something to it? I'm going to, and there's a lot of different ways of doing this, but if I go back into Visual Studio and say File, New, Project, and I'm going to create an ASP.NET web application. By the way, I can go down here and create various types of cloud PaaS type applications, like web roles and worker roles and web jobs, and there's another thing called Azure Functions and so on. But I'm just going to create a simple ASP.NET web application and click on OK. And I'm going to make this an MVC with both MVC and Web API. This actually, I accidentally clicked on the wrong thing. And I'm running out of time, so let me try that again. Something else I wanted to mention before I click on that. So Web Application 2 now. You see here, you can check this checkbox to add the application insight to the project if you want. I'm not going to bother with that. But anyways, so I'm going to click on OK, and MVC and Web API, hopefully you're familiar with what both of those things are. I can host it in the cloud if I want to here, or I can uncheck that and host it locally and then develop it and then publish it to the cloud. So there's many different ways of doing this. But let's go ahead and bring this up with the 5 minutes we have left. And so I'll try Control F5 to run this. So this is going to spin up the development web server on my local machine. It's also going to spin up a browser to view that page all locally, and this is what it looks like on my local host. See that URL? It's localhost port number 50026. So what would this look like on my Azure account? I can right mouse click on here and publish this to my Azure account. And by the way, resource group. Resource groups are a way that the new Azure portal is structured to allow you to group things together into resource groups that have a similar life cycle. So you might have many different projects and you don't want to have them cluttered and mixed. You want to be able to segregate them and compartmentalize them so that you have different groups of components that are combined together into a single resource group, and it makes it much more manageable than what we had in the old portal. So I'm going to go in here, and there's the one I just created on my Azure account. I'm going to click on OK, and it just takes a few minutes to publish it. So down here in the output window, we see that it's building and it's starting the deployment of the package. It's publishing, and when that's done, then we should be able to go back to our browser. That might take this. Let me just put that off to the side, see if we can cover a few more slides here. So we've talked a little bit about what SaaS and PaaS and IaaS are, right? Software and platform and infrastructure as a service. Here's an analogy that helps make it clear. So software as a service is like staying in a rented hotel room temporarily. Platform as a service is similar to leasing an apartment where you live for a long term, but it's not your property and you're not responsible for all that much. You're responsible for taking out your own garbage, but you're not responsible if there's a problem with the heating system, right? Infrastructure as a service is like a private home where basically you're responsible for everything, right? You own everything and you run everything. So hopefully that's helpful in getting a feel for what the differences between these three choices are. I talked a little bit about setting up a subscription. So there are free accounts, there's MSDN subscriptions, there are other possibilities as well. This link here takes you to the calculator on the Azure portal where it tells you where you can make an estimate of what your design you plan on doing, how much is likely to cost you per month. There's also a part of the portal that allows you to actually view the billing history. There's also an API that you can write code to call into to actually create custom client applications and custom widgets within web pages and so on that allow you to create your own custom dashboards that access billing information. There's also documentation here on azure.microsoft.com as well as on MSDN and a lot of samples that you can download. And so an app service plan defines the capacity and resources to be shared among one or more app services. So when you go about and set one of these up, you specify the location somewhere in the world, the number of instances you want to have running, the pricing tier, so that's how much do you scale up, and the number of cores that's scaling out. Instance size is scaling up, and the auto scaling out is the number of load balanced instances. So you can create applications on your own, or you can access pre-existing marketplace applications. There's a huge number of them. But let's take a look at and see if this is finished now. So there it is. You can see that that's on the real internet there. It's like if you go to http://mycooljunkapp.azurewebsites.net, you'll actually see that's up and live and running now. So that's how easy it is to create and deploy a web application to an Azure account. So let's close that. Go back here. I just want you to be aware of the fact that there's a lot of different things that you can create in here. In the marketplace, for example, all kinds of custom applications for real estate agencies and for law firms and for hospitals. And there's a lot of, like WordPress and, Drupal and Joomla, Moodle, EDX, all of these websites that are available, all of these resources are available. And virtual machines, there's all kinds of different versions of Linux that are available, Ubuntu, Windows, Red Hat. You can get a server farm with SharePoint on it, a scale set of virtual machines, SQL Server, Cassandra, Drupal. It's just an amazing set of possibilities there. And data and analytics, you'll find things like Hadoop and SQL Server and HDInsight and Cloudera and all that kind of stuff. So I'm going to close that because we're pretty much we've gone 1 minute over actually, and I only got halfway through my slide deck. But as you can see here, this is the cross-plat console for accessing Linux virtual machines through Secure Shell. All kinds of examples on blobs, tables, and queues and files. Some pretty pictures that with some links where you can take a look at some more details and some specific code examples, which are very interesting. But what I should do now that we're done, we're supposed to be done now. If anyone wants to stick around for a bit more, and if there's any questions, we could probably take them. I'm sorry I didn't finish earlier. But let's see if there are any questions, and also if there's a way for me to provide this PowerPoint slide deck, and what do we do with that?
Yeah, thank you, Peter. Yeah, so go ahead and send me the slide deck. When we send over the recording, we will also provide the slide deck for those people who have attended. So if there are any questions, please feel free to type them in the message box now. So far, it doesn't look like there's any questions, but if there are questions that you decide that you have later, whether it be while you're listening to the recording or anything like that, please feel free to email me, brittany.morin@360training.com, and I'll get those answered for you through Peter to help you guys out. So if there are no questions, then this is being recorded, so we will send that out to you guys along with the PowerPoint that Peter shared. And Peter, thank you so much. Everyone, thank you so much for attending, and that will conclude today's webinar. Thank you, everyone.
Thank you, Brittany, and this is really exciting stuff, and thank you very much for having me, and also sorry about going a little bit over time.
No problem. Thank you.